Hey everybody, this is the Computer Geek 0101010001 here, and today, well, tonight actually, it's 8:19 p.m. Here in the tech room, we are going to be doing a battery rundown test on my APC Smart-UPS 1000, model number SUA 1000. Yep. I have a UPS back in the tech room again. There's going to be a tech room update video coming down next month. That'll go over all of the changes that have taken place here in the tech room within the past year or so. And I believe it's been about a year since I last made a tech room update video. So, let me just give you all a brief overview of what I'm going to do here. Battery rundown test, that's pretty self-explanatory. Now, what I'm going to do is basically, I'm going to interrupt utility power to the UPS and make sure that the UPS shuts down appropriately. And make sure that not only all the computers shut down as they should, but that the UPS behaves itself appropriately. Now to avoid wearing the socket and putting excessive wear on the socket, and the socket that the UPS is plugged into is the far bottom left one to be exact, and so that way all the equipment maintains its electrical ground. What I'm going to do to interrupt power is I'm going to turn off breaker number 29 here in that breaker panel. Now that breaker and the one above it may look like it's tripped, but I can very confidently assure you that it is not tripped, because if that breaker were tripped, that UPS would be on battery power right now. So, let me give you all a brief overview of what's supposed to happen and when. Battery charge is at 100%. At 80%, the Gavin's gaming computer is supposed to automatically shut down. Okay, so if we look at the MBATTCHG, or minimum battery charge field, that tells us at what point does this computer power down. 80% is when this computer shuts down. Now notice that the max time field is set to 0 seconds, and the minimum time and min time L, or minimum time left, field says 0 minutes. That's because the time remaining estimate that this UPS gives out ranges from kind of accurate to off the walls and out to Jupiter inaccurate. And I actually have had to push a custom APC control file to all of these computers so that way they don't freak out and do an early shutdown when the UPS thinks its battery is low, which it makes an ever so critical battery low call off of the time remaining estimate, not the battery charge remaining figure. I don't know why the firmware engineers at American Power Conversion thought that was a great idea, but I'm not a fan of it, APC. I don't know if they've changed that on their SMT and SMC UPSs, or if it's configurable via a firmware configuration flag or something like that. But I would really appreciate it if that was the case, so that way I wouldn't have to do custom configuration just to get the machines to behave as expected. So that way it doesn't go off in screensaver. So, the next machine that drops out after this system drops out is the main office computer at 30% battery charge. Then, at 15% battery charge, the file server and the firewall server drop out. Those fans are not powered by the firewall server, nor are they controlled in any way, shape, form, function, fashion, or capacity by the firewall server. As long as the power supply to those fans continue to have electrical power, those fans will continue to operate, at least in theory. Then that just leaves the APC UPS-D server itself. That drops out at 3%, and it takes the UPS down with it by, I forget what character it sends over the serial port to the UPS. I'm not entirely sure, but I do know that if you send the character Z to the UPS twice with at least a 1 second delay between each character, that will perform basically an emergency power off. The UPS shuts down with no warning. It does not run out its grace period. All load is dropped immediately. And the UPS goes into standby. Now, using that, I could build an EPO switch that not only is an electromechanical disconnect, i.e. it mechanically disconnects the UPS from line power, disconnects the batteries from the UPS, and mechanically disconnects the load from the UPS. It also forces the UPS to power down, whether it be by sending 2 Z's to the UPS with a minimum 1 second delay, or just by cutting off line power and battery power simultaneously, which would completely shut the UPS down and would quite likely be helpful if the UPS does go into a catastrophic fault condition. Hopefully that doesn't happen. But anyways, I digress. The APC UPS-D server, when the battery charge gets down to 3%, the APC UPS-D server will shut down, and it will call the APC control script with the power kill flag, and that will call APC UPS-D itself to send, and whenever it gets down to calling the APC control script, APC UPS-D has already exited. Like, the daemon has shut down and is no longer running. Whenever APC control is called with the power kill flag, APC UPS-D starts back up, sends the appropriate character to the UPS, which tells it to run out its grace delay, and then go into sleep mode, and APC UPS-D exits for the last time, and the computer completes shutdown. Now, I don't exactly remember what grace delay we have on here. We're about to find out. Delay shutdown. Yep, we have a 90 second grace delay. So once APC UPS-D starts up for the last time, sends the control character to the UPS over the serial port, shuts down, that computer has 90 seconds to complete shutdown. That computer has 90 seconds to complete shutdown before that UPS drops out into sleep mode and subsequently drops the load. And if that computer has not completed shutdown by then, I will know about it because I have TupTime installed on this computer, and that will be recorded as a bad shutdown because TupTime is, I believe, one of the very last things to go down before the computer either reboots or physically powers off. So, and I'm not sure if this is the first time the APC UPS-D server running Debian has encountered a full battery drain situation. However, I do know that this is the first time that it's been tested under a full battery drain or rundown situation. So, this is what it's going to look like. I'm going to throw the breaker and exit the room. Now, this is what should happen. That computer, Gavin's gaming rig, that should be the first thing to go at 80% battery charge. Then the main office computer should go at 30% battery charge. Then the file server and the firewall server simultaneously at 15% battery charge. And then the APC PSD server should shut down at 3% battery charge and take the UPS down with it. Approximately 90 seconds after that computer begins shutdown, that computer should have already completed shutdown and the UPS should drop the load and go into sleep mode. Now, if you recall my very recently uploaded, I believe I uploaded that either last night or this morning, power outage video. Yeah, that was yesterday that I uploaded that. Yesterday, the power outage video. You know what this UPS does whenever it dropped into sleep mode. If you do not know what this UPS does, I highly encourage you to go check that video out. It's not a too terribly long video, unlike most of my other videos. It's about 5 minutes and change. It took 11 minutes to render on a GPU. And another thing that I have done, another modification that I have performed to this UPS, to this UPS's configuration, is I have told the beeper to, in effect, shut up and be quiet. Why? Because that beeper gets so obnoxiously annoying you would not believe it. How do I know this? Because I had another UPS exactly like this one in the past. And I made the unfortunate mistake of doing a runtime calibration without silencing the beeper on this UPS. That was about the most annoying 15 minutes of beeping I have ever had. So, literally one of the first things I did before commissioning this UPS is tell the beeper to take a flying leap off of a cliff. Now, UXW Bill also does this trick to his APC UPSs. And for some APC UPSs, such as the lower-end back UPS models, he does a more brute force version of this called, and he coined the term beeperectomy. And basically what it is the UPS is physically opened up and the beeper ceases to exist. And let's move this chair so we can all get a better view of this UPS, of this UPS's load indicator. Now I am going to leave the lights on in the tech room while this procedure is happening. And we have 1 hour and 16 minutes of camera battery charge remaining, so that should allow us sufficient time. That should allow sufficient time for this UPS to completely shut down before the camera battery is exhausted. I know this because in that power failure video I got about 45 minutes out of this UPS. Now the Tech Room Legacy Things computer up there, that is not running APC UPSD. In fact, the reason I don't have it configured up and running APC UPSD is because that computer is off. Is because chances are, when the power drops, whether it be testing or real life incidents, chances are that computer's not going to be on. In fact, Gavin's gaming rig is on more than the Legacy Things computer. Now what I'm going to do is I am going to lock white balance, exposure, and focus. Oh, yuck. Yeah, we're locking that to indoor. Thank you very much, camera. White balance is locked. Exposure is set to manual. And focus is now set to manual. In fact, let's see if we can improve the focus a bit. I don't know. But when this UPS does drop, this room is going to get very dark. And I'll probably end up coming in here with a flashlight to shut the camera off and restore power. Now I'm not going to record the power restoration portion of this test, but whenever the power is eventually restored, what will happen is this UPS will remain in sleep mode, and it will charge its batteries to 15%, and then following its batteries being charged to 15%, it will wait 2 minutes before restoring electrical power and re-energizing the load. And that's 2 minutes with power continuously on. Stand by. Okay, so we are about to throw the switch. 3, 2, 1, go. Those beeps you just heard were computers complaining that electrical power has just been lost. Additionally, you can see that the green light on the UPS towards the left side, just to the right of the load column, has went off, and a yellow light just to the left of the battery charge column has turned on. The tech room load is now being supported off of battery power. Additionally, 2 messages have popped up on the screen of the APC UPSD server. Broadcast message from root at tech room APC UPSD server. Electrical power lost. Unsure if it's a power flicker or AC line failure. That's something I added into the APC control file. Then another broadcast message from root at tech room APC UPSD server. Power failure on UPS tech room. Running on batteries. That is the official acknowledgement of defeat from APC UPSD, saying, yeah, this is a power failure. You're on your own, buddy. So I'm going to be over in here watching. Battery charge is 88%. Battery charge is 88%. 86%. And it's up to 87%. 86%. 85%. So we're not too long from Gavin's gaming rig shutting down. 4%. Let's go ahead and focus up on Gavin's gaming rig. Let's see, 82%. That computer should be shutting down. 81% of any second now, literally. Whoop. And there she goes. 80%. Gavin's gaming rig has shut down. Or at least it's about to shut down. Under command of APC UPSD. Oh boy, what's holding up the shutdown process now? That's where half the time this thing tries to do a shutdown, it hangs up. Yeah, so let's look at the console and see what's got her hung up. Oh, printers. That'll cut out in a minute and a half. Yeah, probably some Ubuntu crap going on. This machine's due for a Debian switchover anyways. So let's go ahead and look at our statuses. We are at 64.3% load, 72% battery charge. UPS thinks it has roughly 9 minutes of battery time remaining. That's probably out to Jupiter inaccurate. Output voltage is 120.1 volts AC, 119.4 volts AC. somewhere between 119 and 121 volts. And Gavin's gaming rig has just completed shutdown. Load has dropped to roughly 55%. Battery charge is 69%. Time left has increased to 11 minutes. Let's go ahead and turn off the monitor for a more complete shutdown. And you can see the status flag says on bat or on battery. The outlets that we were looking at earlier in this video no longer have any form of electrical power. I can take a multimeter and put it to those outlets and I would get nothing, 0 volts. In fact, even the UPS agrees with me, 0.0 volts because the breaker is turned off. It does not seem like it in here because everything's still lit up and lively. But I can guarantee you, in not too long from now, yeah, it's going to be a little bit different. So, let's just zoom back out and see the changes. Let me see, Gavin's gaming rig has powered down. The UPS indicates it has somewhere between. UPS indicates 3 bars on the load graph and 3 bars on the battery charge graph. And that it is indeed on battery power. We zoom back in over here. 52.6% load, 60% battery charge. It thinks it has 10 or 11 minutes of battery remaining. It's putting out 120 volts. It was putting out 0.3 of a volt under 121 volts. 90-second grace delay. I don't know what this LOBATT thing is. Whatever it is, it doesn't matter since I've explicitly configured APC UPSD to ignore that setting. Additionally, if we look at our low trans and high trans fields, we see 100 volts and 130 volts. The low trans field indicates the point at which the UPS should cut to battery power. And I have that set at 100 volts. Now, AC line specification states that AC line spec is nominal line voltage plus or minus 10%. All full range power supplies should be rated to the lowest countries, to the voltage of the country with the lowest line voltage, which is Japan, minus 10%. So Japan has a nominal 100 volt AC line system, minus 10%, that's 90 volts. So 90 volts is the lower limit for full ranging power supplies. Now, and they should also be rated to the country with the highest voltage line system. So take that nominal voltage and add 10%. Much of Europe uses a 240 volt line system, 240 volt AC line system. So you can add 10% to that, and you get 253 volts. Now, in some countries with not so great power regulation, the nominal line voltage tends to float around 250 volts. Add 10%, and you get roughly 263 volts. And high trans is 130 volts. And our power line system is rated. Our power line system is a nominal 120 volt system. So high end is 132 volts, and the low end is 105 volts or somewhere around there. So 100 and 130 is a pretty good range for that. Battery voltage is down to 22.5 volts, roughly. Nominal voltage of 24 volts. The last transfer reason is a line voltage notch or spike. In this case, it's a notch to 0. There have been a total of 4 transfers. We went on to battery at 2037.58. Time on battery, 549 seconds for this transfer event. And cumulative time on battery is 560 seconds. The last time we transferred off of battery was this morning at 8:16:07. I don't know what happened there. I'm willing to guess the well pump started and the UPS didn't exactly like that. The last self-test was 4 days ago at 20:56:46, and it seems to have passed. So, if we go up in here, our battery charge is now 41%. Our load percent is 52.6%. The UPS thinks it has 7 minutes remaining. And as I said, the time remaining figure on this UPS is usually out. It has usually went out to lunch and gone on a field trip to Jupiter. It's that inaccurate. And hence the reason why I have explicitly configured APC UPS-D to completely ignore that low battery figure. So we are now 10% away from the main office computer and shutting down under command of APC UPS-D. So UPS seems to be holding up fine. 39%. Yeah, that sense high figure, that is the line voltage sensitivity of the UPS. I thought I set that to medium. I guess not. So that explains why the UPS kicks off the battery every single time the well pump seems to start. Either that or the line voltage rides just a hair bit low. Couple that with the well pump starting, and that thing has quite a bit of inrush currently. It starts, by the way. And there you go. Yeah, thought I set that to medium. I need to set it to medium. So that way I don't prematurely wear out the transfer relays. So we are now 5% away from the main office computer shutting down. 4% away. So I'll go ahead and kick this chair out of the way. 34%. 31%. Let's go ahead and kick over to the appropriate input on the KVM switch. And the main office computer is about to enter shutdown. That black box you see there on the screen is a courtesy of a Xscreen unlock dialog that isn't exactly rendering properly. It does that every once in a while. But I imagine our battery charge is about to slip past 30%, which it has just done. The main office computer has just completed shutdown. The next two machines to go down will be the file server and the firewall server at 15%. There's the firewall server. So far, so good. Now, if something does go wrong, such as the APC UPS-D server fails to shut down properly, or a computer shuts down too early or too late, or the UPS gets put into the wrong shutdown mode, this is why I do these tests. So that way I can identify problems now before the real thing happens. So load is down to 43.5%. The UPS still thinks it has 7 minutes remaining. Meanwhile, I've been rattling my head for almost 14 minutes now. Oh wow, the load percentage dropped and it thinks it has 6 minutes remaining. Great compensation there, APC. Battery charge is down to 29%, and I'm running out of things to ramble about. It's going to be a pretty slow crawl. It's going to be a pretty slow crawl down to 15%. So I am actually going to stop the camcorder, and we'll come back as we approach 15% battery charge. Actually, you know what? Scratch that. I'm going to turn the camera on. I'll point it right here, and you can watch. You can watch the battery charge tick on down. Battery charge has just reached 23%, and in the second light on the load bar on the battery charge graph is starting to flicker away. Well, not exactly yet. There it goes blinking. I don't know if that is derived off of the time remaining figure, or if that's derived off of the actual battery voltage relative to the battery cutoff voltage. And there it goes blinking out. So if we look here, our battery charge is down to 22%. Load percentage is at 45%. It's kind of floating around. UPS thinks it has 4 minutes remaining. I can guarantee you it's 5 minutes remaining. I can guarantee you it might be 5 minutes until it's probably going to be maybe 4 or 5 minutes before we finally creep down to 15%, and the last two machines go into shutdown. Additionally, the load bar on the UPS is down at 2%. 2%. The load bar on the UPS is down to 2 lights. Now, I can guarantee you that in a real-world power failure situation, where like the lamps were off and whatnot, it would be longer before this UPS. I would get more run time. Yep, there, the UPS. Yep, okay. Yep, we are about to be in the dark. And there, yep. That's why I do these tests, because I have not tested the configuration of this UPS, of the APC UPSD server, since I moved it to Debian. We are about to be in dark. Seconds can seem like quite a long time. And there it goes. Okay. I'm glad I ran this test. Okay. This is why I run these tests. This just highlighted a flaw in my testing. Not in my testing, but in my configuration. What should have happened is when the battery graph, when the first LED in the battery graph, the battery charge graph on the UPS started flashing, nothing should have happened. And what actually, because that battery graph, I believe, is given from the time remaining estimate, which as we know now is completely out to Jupiter, because I think it still had 22 or 21% battery charge remaining, and it went into shutdown. In fact, I'm actually going to go ahead and turn the breaker back on. So the breaker is now back on. The UPS's battery charge is already above our minimum battery charge threshold. So now it'll be about 2 minutes before that UPS powers back up. So So I need to take my APC control file from one of my other machines, and I need to move it to the APC UPSD server, because I know that the last time we had the power outage, which was that day in July, this didn't exactly happen. And here the fridge just kicked on, so yeah, power's on all right. But this is why I run these tests, because depending on what I was doing, let's say the power fell down the road and I hadn't run this test and discovered this problem, depending on what I would have been doing at the time, that could have ranged from mildly annoying to near catastrophic for whatever I was working on. So, I think we're starting to get real close to the UPS coming up out of standby. We'll just watch it sit there and flash its lights for all of eternity. But when that UPS comes up, it's going to do a self-test. And it's going to do a self-test, and the APC UPSD server, as configured by its BIOS, is going to auto-start. Now, this is probably going to be one of the more interesting of the battery rundown test videos, because in this particular battery rundown test video, we exposed a flaw in the configuration. Now, I'm also glad I kept the light in the utility closet switched on, so I'm not standing here completely in the dark, as you can tell. So, I don't know what caused the other two computers to shut down like they did. I was expecting them to completely ignore it, and I was expecting those two to go down hard when the UPS dropped, but they didn't. Probably because the APC UPSD server sent the message out, hey, we're going down here. And those two computers did an emergency shutdown. Now, I'm glad that happened, because it would have been mildly inconvenient had they went down hard. Because, and also would have registered a bad shutdown in time. Now, I know the file server went down as it should have. I also know the APC UPSD server went down as it should have. I do not know if the firewall went down as it should have. I didn't bother getting down and looking at the power lights on it. I could see that at least one of the network controllers was still linked up, probably at 10 megabit half duplex if it was shut down, or gigabit full duplex if it went down hard when the UPS dropped its load. Okay, UPS, when are you going to kick on? But this is the sleep mode that I'm talking about. It's different from a regular shutdown in that the UPS will automatically return. Will automatically switch itself back on, bring the load back up on line power. Whereas a regular shutdown will command, the UPS just shuts off. It'll run out its grace period and then act like you went over there and mashed the off button on it. And I would have to manually come in here and turn the UPS back on. Now, at least I believe that the battery charge was higher than 15%. That or this 120 seconds is going forever. We're at 10 minutes and 43 seconds on the camcorder. So, yeah. So what I need to do is, I need to figure out exactly what I did, so that way when the UPS says its battery is low, which it gives that ever so critical figure off of the estimated time remaining, instead of the current battery voltage relative to the battery cutoff voltage deriving a percentage off of that, I need to figure out what I did to make the other machines ignore that, and I need to do the same modification to the APC UPS-D server's configuration. If we look at the MBATTCHG, or minimum battery charge field, very funny. Add that one to the blooper reel.